Hello and welcome to this dress rehearsal for a presentation at Knowledge16. My name is Joe Bauer and I'm an IT process manager at the University of Michigan. This is a story about the differences between top-down centralized control versus distributed coordination, the benefits that we got from making that change along with some specific ServiceNow features we're using to help us get there. While I tell this story, you'll hear this problem. Control led to segmentation of people, process, and technology, and over-customization. And that all led to hazy goals for CMDB, inconsistent processes, and complexity. As a result, there was a lot of manual effort, which led to untrustworthy data. And this story is about how we went from a control-based environment to a coordinating one, and the changes that we made along the way to enable that. But first, just a little bit of background. So at University of Michigan, we have a very decentralized organizational structure, and there are over 36 IT shops on campus, ranging in size from one person to several hundred. I come from one of the larger of the IT departments with almost 1,000 staff members. We handle things like HR and financial systems and student records and donor alumni development systems and so on. And when I say decentralized, what I mean is that we have many distinct IT organizations, and most of them operate quite independently of each other. The distributed nature of higher education is something that has occurred kind of on purpose. It's an organizational model that has served academia and scholarship pretty well, and it allows for flexibility that enables higher education organizations to persist for longer than many other types of organizations. To show what I mean, I've got a little timeline here. Yeah, you know you're at a university presentation when the overview covers 1,000 years of history. But I'll be brief and spare you the Western Civ 101 lecture here, and I promise it'll make sense in here. So here we have a little timeline with a few major events in Western civilization and US history. And these are presented just as context, reminders about how deep history can get. For example, when you look at the NASDAQ's top 10 companies in terms of dollar volume, the entire history of all those companies fits within this space right here. And I point this out not to diminish their contributions to humanity or to make them seem small, but because these organizations are really good at what they do. I'm displaying this timeline to illustrate the depth of what I mean when I talk about the longevity of higher ed organizations. The University of Bologna was founded back when the Holy Roman Empire was the ruling government, back in 1088. University of Naples started in 1224 under the Kingdom of Sicily. University of Oxford, established back in 1096, saw several kings, multiple governments come and go. I can go on, but what I want to get at is that University of Michigan, established in 1817, about 20 years before Michigan was a state, is a young whippersnapper of a university at nearly 200 years old. And the broader point here is that the longevity of these institutions can be traced back in part to their decentralized nature. However, there's a consequence to this organizational approach. So centuries of accreted culture can make coordinating activities across the entire organization very difficult, especially if you must coordinate something like IT or IT process. And changing this institutional culture is something that is not easy to do, and you'll hear some echoes of this throughout the presentation today. So back to present day. So for our IT department, our environment has about 140,000 CIs spread throughout about 63 different classes, things like servers, computers, databases, some network gear, printers, business services, business applications, and so forth. And there are dozens of teams within our IT department that have some sort of accountability or responsibility for this data. A pretty common relationship structure in our CMDB looks a bit like this. It goes from a business service down to infrastructure bits. And in this example, it all actually goes all the way down further to VM host clusters and racks and a data center, but just not enough room to really show all of that right here. But for CMDB, we had hazy goals. And we didn't see a path to success or even know what success looked like. We knew we needed a CMDB and it was important, but it was difficult for people to understand how it was different from an inventory spreadsheet or an infrastructure architecture diagram in Visio. And we had those already. In our old approach, we also had centralized the control of things, and the biggest and loudest teams or groups frequently got whatever they wanted. On top of that, we had taken kind of a top-down command and control approach to our CMDB implementation. Only the very few teams at the apex of control could update or even view records, even if they owned the assets or were responsible for managing it. This led to spreadsheet proliferation, as each team still tried to control their portion of the process. And control cascades through a hierarchy and promotes barriers or territories of isolation, thus creating redundancy and also fostering mistrust between isolated teams. And it's a self-perpetuating process that snowballs, and only a small number of teams were trusted with updating the data. The idea was that we'd have bad data if just anybody were able to change it, and way too much effort was spent trying to fight the designed functions of ServiceNow in order to reinforce these boundaries of our territories and to control information going between our teams. The desire for control didn't stop at the process or people level. It made its way all the way into the way we supported ServiceNow. Instead of fostering coordination between teams and automating handoffs, we attempted to reinforce the isolated territories of control by customizing ServiceNow, often in contradictory ways. And our customizations led to some pretty severe and frequently confusing complexity that took up so much time and effort that our support team was buried in a backlog of work and just couldn't keep up. Here's one small example of our customizations. Here we have the incident form. Over here you see assigned to and secondary assignee. Secondary assignee is a University of Michigan invention. So customized code had to be created to make sure that it behaves just like assigned to. And time and effort has to be spent to make sure that all the other ServiceNow functions that reference or use assigned to also work with secondary assignee. So every time there's an upgrade or any kinds of other new functionality added, we have to work on that. Then over here, there's the business service and configuration item. Of course, a business service is a configuration item, and sometimes you'll see those both on a form, but in our case, these two are not linked to each other or related to each other in any way. But our masterpiece is really down here where we've got the catalog order as one of the incident categories. So you might be saying, wait, request within incident? Yep, that's we put request fulfillment inside the incident management form with the addition of this single drop-down option. And well, it was easy. You just add an item to the drop-down. What's the big deal? But it was these kinds of small customizations that added up to complexity that broke down our capabilities over time. So often we were unable to use core or basic functionality of ServiceNow because we had customized things like this, or a table or reused field for some unintended purpose. And because of this simple addition here of catalog order, for example, we could no longer use request fulfillment or request workflows because it was all handled in incidents now. And because that work of requests couldn't be tied to workflows to enable or automate the tasks of fulfilling that request, our CI and asset record updates all had to be done manually after an incident record was closed. So if you moved a workstation, for example, you had to update a minimum of 3 records: an incident, a CI, and an asset record, and maybe even a spreadsheet or 2 on top of that, depending on what you were doing. And these kinds of record updates were often put off to later, forgotten, and the data accuracy drifted severely. And also, most of the people who were doing the work of the incident records didn't have access to update assets or CIs anyways. So they had to queue up a list of things by hand to hand off to someone else to enter, usually with yet another spreadsheet. This, as you can imagine, led to pretty bad data accuracy and very little trust in the data in ServiceNow. And because of this, entire wall-to-wall inventories became very frequent. And since individual teams didn't always have access to update the data in ServiceNow, we also saw multitudes of spreadsheets and shadow processes popping up. And over the winter, we did a quick book to floor and floor to book audit on workstations and printers, where we randomly selected some records in ServiceNow and had about 80% success when we tried to locate them out in the field. And with Floor to Book, we randomly selected some workstations and printers out in offices and labs and such. And we're only able to find matching records in ServiceNow for about 50% of them. So here I've got an oversimplified model of the SACM lifecycle, the asset and configuration management lifecycle. Basically, we buy things, we use things, and then we dispose of things. And in the case of the workstations and printers, ours was an environment where each team had their own slice of the overall SACM process and their own spreadsheets, and none of them could see each other's data. And the teams couldn't see what each other were doing. And further, Tier 1, our service center, had nearly no visibility into any of this other than what little was in ServiceNow, which was pretty inaccurate and absent from most of the asset's life cycle. So answering the simple question of where's my stuff after someone makes a request was really pretty difficult and time-consuming question to answer. And all of that had the effect of putting up big brick walls between teams and between major process flow steps. Here you can see the effects of that cascading control I had mentioned earlier. And I'll talk about ServiceNow's involvement in a moment, but it was a telling moment when they asked our teams how they thought the SACM process was going. And initially, they all said it was just fine. When you see it this way here, each team was kind of only looking at the activities in their own territory of control and not considering the functionality, the capabilities, or efficiencies of the process as a whole. It wasn't until teams looked at the whole process that the gaps and challenges were identified. So with our data in such bad shape and our capability to perform core process and technical functions, clearly we needed a new approach to the way we handle things. And so last fall, we had ServiceNow come out and hold a workshop with us. And they observed and interviewed us, gave us some recommendations, and then they helped us start to untangle our mess and putting in place a more solid foundation upon which we can achieve coordination, which we believe will lead to more accurate data in time. So for many people, the idea of using coordination instead of control in a large, complex environment sounds a lot like chaos. But it's context setting that makes the use of coordination powerful. For example, there's no single leader directing and controlling this flock of auklets, yet somehow they all have the ability to swarm and avoid predators in a low-cost, highly coordinated fashion, which makes the entire unit look as if it's behaving as one in an intelligent manner. It performs this by each individual auklet knowing and understanding a basic context and being able to take environmental factors and adapt based on the parameters of that basic context. No individual auklet has to take on the cost of coordinating the entire flock. It just has to concern itself with operating within its own position within the agreed upon context. In an organizational setting, the context can take a form of standard processes, common language, and universally agreed upon goals and objectives. To enable ourselves to have the best chance to move toward coordination, we set common goals and common standardized processes, roles that enable people to perform their expected coordination tasks. And then, importantly, we started to put many of the tasks of coordination in ServiceNow itself. As a way to mimic the hundreds of thousands of years of evolution that these auklets have had to make a lot of what they do second nature and not necessarily a conscious activity. So in other words, we put a lot of the mundane and expected coordination behavior and actions into ServiceNow so that the people involved with the process activities could be left to higher order tasks that will eventually allow our flock to appear to move as one. So from our original problem, this took on the issue of control. You'll see later a few more specific examples of how we enabled others to coordinate instead of controlling them. So with the help of ServiceNow, who introduced us to this ISO model of the tiers of asset management. We set a common and agreed upon goal of establishing trustworthy data. And this was something that seemed easy to understand and was easy to tell a real world story about. And it's easy for people to see themselves in the story and see the real world value. And the what's in it for me question was not that difficult to answer. Where it got tricky in the past was where people wanted to do lots of really cool things in these other tiers here. For example, we would attempt to improve efficiency or improve management controls, but these efforts commonly fail because none of this is possible without a foundation of trustworthy data. The seemingly small and easy to understand goal of trustworthy data helped keep us focused because when working with this kind of a thing, that it's very easy to find yourself straying off into tier 5 and trying to boil the ocean. It's also a great expectation setting tool. So many people who expected us to be at tiers 3 or 4 could understand with just a little bit of description how we're trying to set up tier 1, and that while the other tiers aren't going to happen right now, we're definitely setting the foundation for them in the future. And so discussions that used to end in frustration because of mismatched expectations were starting to end with a little bit more hope and excitement. So this took care of the hazy goals part of our problem here. Because we were sitting on such a pile of complex customizations that limited our core capabilities, we saw one of the primary ways for achieving our new goal of trustworthy data as getting ServiceNow back to so-called out of the box, or in other words, to get back to and use best practices configurations. And this meant we had a lot of data and interface re-engineering to do in order to get things back to how they were meant to be. It also meant that many people and many teams had to rethink how they did their work. So going back to out of the box went a long way to reducing our customizations, and you'll see even more examples of this pretty soon. So speaking of which, let's just dive in and look at some of those specific examples of things that we changed and how they helped us out. One of the first things we tackled was around roles. And first, we took the best practice processes and their functional and process roles and established those as our standard roles. Then we went through and made sure that there were system roles that matched those. So the people in those functional and process roles would be able to perform their expected activities within ServiceNow. See, before we just had one single super asset role and that role had admin-like powers. If you didn't have that, you basically had nothing. And that meant that quite a lot of people didn't have the ability to do what they're supposed to do in ServiceNow, even if they wanted to. And since we were standardizing on one SACM process, we had a few roles that needed to be able to do work to do their part of the process. And a single super asset role wasn't going to cut it. So we followed best practices and added roles for asset analyst, asset owner, CI analyst, and CI owner. For a CI, you would get the owner role if you were assigned to it. So for a workstation, this would be the end user. And yes, they are allowed to go in and update their record if they see an error. Then there are the analyst roles, which for CI is the support group, or the group responsible for the daily care and feeding of the CI. One of the reasons there are asset versus CI versions of the same role is because that can account for the common situation where one group owns the asset and has financial responsibility for it, but the different group manages and supports it. In our very decentralized environment, this is a capability that's very useful because it occurs quite often. For example, with cases of sponsored research, or where an academic unit will purchase an asset but then hire out another unit to manage it for them while different members of their unit use it. So with roles and process in place, we were able to chip away at another part of our original problem, the inconsistent processes. Another major change we made was to bringing our data and data structures back to best practices, or more closely to out of the box. And a few examples are with the CI statuses. Here's some of the CI statuses that we used to have, and then how we map them to the more standard CI statuses in order to get closer to best practices. And you'll see that many of our old CI statuses seem to try to duplicate asset states. Because of limited visibility and knowledge, there was often confusion on what the differences were between asset record and CI record, which led to many customizations that often blurred the lines between the two record types. And here again with the asset states. It was our function field that was the most fun. And function, of course, is not an out-of-the-box field, but it's one that ServiceNow recommended as a best practice for our personal computers class. Our old version of it was called used for, and which ended up being kind of a grab bag of drop-down options that were logically inconsistent or contained items that we should or could have been derived from combining other data. So you can see here we had gone so far as to duplicate asset states here, like in use, for example. Another example of taking things back to best practices is with our CI form. Here's an example of the old computer class form. You can see there's a jumble of core information, general information, and configuration information. And also some fields that don't really make sense to a lot of people, like this other association. And below that, we have a field for manually inputting which software image might be installed. The options contained images from one of the workstation support services. And then this reason field, for those that were in the know, is supposed to be used to describe why a computer didn't have a certain service standard software build on it. Also, note the emptiness of all these fields. This is a very common occurrence here. As you scroll down on that old CI form, you come across the configuration portion, which you can see that emptiness continues. But back then, we didn't have any of our network discovery tools feeding ServiceNow for configuration data on workstations. So here's what the new CI form of the personal computer class looks like. It's a lot closer to out of the box. It's more streamlined, and the data types are clustered to make it easier to find information. So the core information is at the top half here. It represents the information that is most frequently used and is most important to keep up to date and accurate. And then the general information down here is new bits of information, like the last logged in user and when the CI was last discovered and by which discovery source. This is kind of handy information to have when you're trying to troubleshoot data accuracy issues. And the configuration information found here is none of this is entered by humans. It all comes from network discovery, and you can see that a lot of it's populated. And part of the work that we did was to connect the management tools like SCCM to ServiceNow in order to feed it that kind of discovery data from over the network. And this security tab is brand new for us and really allows us to take advantage of the relational nature of the CMDB. If we identify a business application as needing to adhere to one or more of these compliances, then all the CIs related downstream to it inherit that attribute. And this way we can quickly and easily see if a CI has to comply with any kind of specific security-related regulations. A major part of managing the overall life cycle of an asset is understanding in which part of the life cycle it currently resides. Through data structure and form structure cleanup efforts, we were able to assure some level of accuracy could be maintained, but we needed other ways to ensure that we could capture and act on any errors in data as they occurred, something of a safety net, if you will. And one way we were able to do that was through data certification. As an example, ServiceNow provided us a list with expected state and status alignments. So here's a sample. The list goes on, but this is, we'll just focus on this one line here. So when an asset is in use, it is expected that the CI status is also installed. So if the asset says it's in stock and the CI says it's installed, clearly there's an issue. One of those records has to be incorrect. It can't be both on a shelf and also on somebody's desk. But in the old way of doing things, we'd never know that there was an issue because one team dealt with the asset while a different team dealt with the CI kind of information, and we had no mechanism to audit the two in any kind of timely manner. So enter data certification. We encoded all those expected pairings into criteria for data certification filters in ServiceNow. So it is able to find all of the cases where the states and statuses are not aligned. And then it assigns data certification tasks whenever it finds one of those mismatches so people can investigate the issues and we can keep our data cleaned up along the way instead of waiting for an annual wall-to-wall inventory to find all of these kinds of issues. And this is another example of where we started to offload effort onto ServiceNow in a way that brought the work of multiple teams together. So with customization reduced, data structures back to best practices, the form simplified, and the roles clear and more fully understood, we were able to drastically reduce the complexity. And now that the data is being auto-populated, we are able to mark off the manual data entry part of this problem as well. So next we focused on segmentation. So now that we had this foundation, we were able to start moving away from this to this. So now ServiceNow is positioned as the source of truth for hardware asset lifecycle data. This means that the lifecycle data is in ServiceNow and all the teams that touch a part of that lifecycle have access to the same data. But it also means that we now have the opportunity to exploit many of ServiceNow's features for automation where previously they were unavailable to us. We're also finally positioned to be able to take advantage of request fulfillment and request workflows in order to automate the activities of the SACM lifecycle process even more. Being positioned to take advantage of this type of cross-team automation is a major win, especially when you think back to my little history lesson at the beginning of this presentation. So combination of roles, the unified processes, the unified tool implementation allowed us to check off a segmentation problem since now teams can coordinate between each other while maintaining assets within their life cycle with much lower effort. You can see that we've checked off quite a few boxes in our original problem. It's still a little early to tell if we've made permanent and lasting change in our trustworthy data, but in addition to all the benefits I mentioned throughout this presentation, early indications are positive. For example, with the new roles, processes, and technology changes, we were able to quickly and efficiently identify almost 1,800 workstations and laptops that were previously unaccounted for. So that's about $1.5 million worth of assets back on our books and accounted for. So to summarize, some of the key lessons we learned from this experience were to really lean on process and technology to shoulder the burden of coordinating so that you don't have to centrally control and direct everything, and each team or department doesn't have to spend effort and resources reinventing the wheel. And for us, we found the central command model to be unsustainable at scale. We also learned that in order to distribute control and enable coordination, everyone involved needs the correct system roles and process or functional roles in order to do their part of the process. And we learned that in order to use the processes and tools in a distributed way with lots of people, we had to go back to standards like out of the box and best practice configurations for ServiceNow. So the key takeaways for you to consider if you're going to manage a CMDB are to think about coordinating instead of controlling. Use ServiceNow to take on the burden of the coordination tasks and automate wherever possible. And finally, to follow best practices. It's the common language, expectations, and activities that can glue all this together. So with that, pause for any questions. Thank you.